Welcome to our channel. In this video we are going to discuss electrolysis and the Faraday's law of electrolysis. Electrolysis is a chemical process that involves the decomposition of a compound using electricity. It's a crucial technique in various industrial processes and plays a significant role in fields such as metallurgy, electroplating, and the production of chemicals. Water is a polar molecule. It has a positive and negative poles. This makes it susceptible to electrical forces. It is also one reason why it is able to dissolve solute of wide range. It has two hydroxyl bonds. Each bond requires bond dissociation energy, also known as BDE. This is the energy required to break the bond. Another interesting fact about water is that it undergoes autoionization. This is also known as self-ionization or autoprotolysis. It is a chemical process by which a molecule spontaneously ionize itself. In the case of water, autoionization refers to the process where water molecules dissociate into ions without the presence of external factors such as acids or bases. The equilibrium constant for water is given by the expression. This is based on the concentration of hydronium ions and hydroxide ions. Based from this equation, we can calculate the number of free H+ ions in 1 liter of water. We see that the number of ions at a given time in a liter of water is nearly constant. This makes water able to conduct electric current best when not pure. Electrolysis is made possible by oxidation reduction reactions at the anode and cathode of an electrolytic cell. Although hydronium and hydroxyl ions are present in water itself, the oxidation and reduction of H2O is more favorable due to the following reasons. Higher concentration of H2O compared to hydronium and hydroxyl ions. Low overpotentials. And reaction kinematics. At the positive terminal, anode, oxidation takes place. H2O loses electron. Water loses electrons. The equation would be: at the negative terminal, cathode, reduction takes place. H2O gains electron. The equation would be: we will now add the half reactions and get as we are expecting. At the electrodes, the ions gain or lose electrons, resulting in chemical reactions that lead to the decomposition of the electrolyte into its constituent elements or ions. In case of other ions dissolved in the solution, positive ions, cations, migrate towards the cathode, while negative ions, anions, migrate towards the anode. How can we compute for the mass of the substance collected at the terminal? Michael Faraday formulated the Faraday's law of electrolysis. The first law of electrolysis states that the mass of substance deposited or liberated at an electrode during electrolysis is directly proportional to the quantity of electricity passed through the electrolyte. The formula is given as, where m is the mass of the substance deposited, Z is the electrochemical equivalent, and Q is the number of charge that passed through the circuit. To illustrate this, let us answer a sample problem. Calculate the mass of hydrogen gas liberated at the cathode when a current of 2.0 A is passed through water for 1.5 hours. Assume complete electrolysis of water. We are asked to find the mass of the hydrogen gas. We are given the current, the time, and we should know that electrolysis of water produces 2 moles of hydrogen gas for every mole of oxygen gas. The molar mass of hydrogen, H2, equals 2 gram per mole. We can solve for the amount of charge using the formula. Q is equal to current I, times T. We see that the electrochemical equivalent for water is. By substituting the values to the formula, we have 0.112 grams of hydrogen gas produced. Thank you for watching. Up next would be the Faraday's second law of electrolysis. If you have questions and comments about this topic, please write it down at the comment section below. If you want a copy of the slides, please see the description box or scan the QR code.